Okay, right now we're going to talk about area of a sector. And we just got done talking about the crust of our pizza, our Trig. Now we're going to talk about area of a sector. Well, area of a sector is more like the whole pizza slice. Okay, so if I'm looking to figure out what the area of this sector is, I'm really looking for my pizza slice. How much pizza do I have in my pizza slice? Okay, so that's what a sector is. To find the area of a sector, you're going to do 1/2 times the radius squared times your angle again. Angle again in radians. Okay, so make sure that this theta is in radian. Radian measure. All right. Here we go. Find the area of a sector formed by a central angle of 1.4 radians and a circle of radius 2.1 meters. In order to find the area of a sector, we're going to do 1/2 times my radius squared times my angle in radian mode, radian measurement. What is the radius of this circle? 2.1. What is my angle? And it's 1.4 radians, so we don't have to convert it. That's too easy. Put it all in your calculator. Make sure you do it in the correct order of operations. 2.1 squared times 1.4 divided by 2. I think in this it won't matter because you're just multiplying the numbers. .09 if we round it to decimal places. 3.09 what? Meters squared. And so my pizza slice, the area of my whole pizza slice would be 3.09 meters squared. Okay with that? Okay, so another one. If the sector formed by a central angle of 15 degrees has an area of pi/3 centimeters squared, find the radius of the circle. So now, they give me the area of my sector, right? They give me a degree mode, or degree measurement. Now they want me to work backwards and figure out the radius, okay? Can I start with the formula? Plug in what I do know, and let's see if we can work backwards. So what is the area of this sector, this pizza slice? pi/3. My 1/2 is still just a number, right? 1/2. What is the radius of this circle? We don't know, so let's just call it r squared. And what is the angle? But I don't want to put 15 in there. What do I want to put in there, or what do I need to do with the 15 anyway? Convert it to radians, right? Because this angle doesn't mean degrees, it means radians. So if you need to off to the side, convert your 15 degrees to radians by doing pi/180. So how many radians is that? 4 /12? Everybody okay with that? pi/12? All right. Now we're solving for r, correct? We want to get that r by itself. Can I simplify this right side by putting these two fractions together? On top I have 1 times pi, so can I call that 1 pi or just pi? On bottom I have 2 times 12, can I call that 24? Just taking those two fractions and combining them. Can I do that? So now if I want to try to get r by itself, I need to get rid of the pi/24 and I need to get rid of the square. I'm going to get rid of the pi/24 first. How would I get rid of that pi/24? Normally you would divide, right? But we normally don't do like a quadruple layer fraction. That looks kind of weird. So instead of dividing by pi/24, could I multiply by 24/pi, multiply by the reciprocal? So I'm going to multiply, put in the wrong spot. Multiply both sides by 24. That's not a 24. That way, those would go away, and I would just have an r squared left on that side. Over on this side, the pi's go away, don't they? And what am I left with? 8. And so now how would I get r by itself? How would I get rid of the square? Square root of 8 can be broken down. Can I factor tree that? If I factor tree it, I get 2 rad 2. Normally when we square root things, don't we do plus or minus? But if I'm talking about the radius, there's no such thing as negative 2 inches of a radius. So I'm going to say just positive 2 rad 2. 2 rad 2, what was this in? Centimeters? So the radius of this circle would be 2 rad 2 centimeters. You okay with that? Radius is just the length of the radius, so we're just going to do regular centimeters. It's only square when you do area. Okay? So radius is always just regular units. Arc length is just regular units, but area is square. Okay? Question? All right, let's do another one. All right. A sprinkler located at the corner of a yard is set to rotate through 90 degrees and project water 30 feet. What area of lawn is watered by this sprinkler? Okay. So if you kind of look at the picture, it's set here for 90 degrees, and it's supposed to shoot water here 30 feet out. And we want to figure out how much of this lawn is being watered. So what are we looking for? Area of that sector, right? Our pizza slice, our slice of lawn in this case. So in order to find the area of our sector, we need to do not S, I only do A for area, sorry. Area of our sector is 1/2 radius squared theta, right? 1/2 is just a 1/2. Do I have a radius here? Wouldn't it be 30? If you were to continue this circle all the way around, it would look like a big circle with a radius of 30. Times theta. What would the theta be in this picture? Pi over 2. I like that better. Not 90, right? Because we want to convert it into radian degrees. So I'm going to do pi over 2. All right. In your calculator then, you're going to do this. 30 squared times pi divided by 2, divided by another 2. Let's get the area of this lawn. Is that right? 706.86. What's the units here if I'm talking about the area of the lawn? Feet squared. So that's how much lawn that sprinkler should water. Good? Okay, so make sure you memorize those two formulas.